Hello everyone, today we are going to solve few questions on acceleration due to gravity. There are three cases based on acceleration due to gravity. Case 1 is if the object is on the surface of the earth. If it is on the surface of the earth, then the gravitation is given by gm by r square. And in terms of density, we can write it as 4 by 3 pi rho gr. If the object is above the surface of the earth, then we can write it as g naught into r square by r plus h the whole square, where g naught is the gravity of the earth, r square is the radius of the earth. If the height is very small than the radius of earth, we can write it as g naught into 1 minus 2h by r. And last, case 3, if the object is below the surface of the earth, we can write it as g naught into 1 minus e by r. So using these formulas, we are going to solve questions. First question is, at what distance below and above the surface of earth a body will have same weight? It is given that r is equals to radius of earth. So here it is given that the object is above and below the surface of the earth. So case 2 and 3 will be applied. So for above the surface of the earth, the formula is given as g naught into r square by r plus h the whole square. And for below the surface of the earth, we need to apply case 3. Here they are given that it has to have same weight. So if the weight as mass is constant and weight is same, then their both gravitations are also same. So we will equate equation 1 and 2. Here they are asking at what height. So instead of taking this as distance d, we can write it as distance h. So when we equate these two, g naught gets cancelled, and we can write this in simpler form as 1 by 1 plus h by r to the whole square. Here we can apply the formula a plus b into a minus b. Instead of taking h by r, we will simply substitute it as x. So 1 plus x into 1 minus x square equals to 1. So we need to solve this equation. quadratic equation, we can solve this and we get x is equals to under root 5 minus 1 by 2. Here we cannot take minus root 5 because x will come in terms of negative. We don't want it in terms of negative. So we know that x is equals to h by r. So we get the height in terms of r as r by 2 into root 5 minus 1. At this distance, the body will have the same weight. So this is our second question. Assuming the Earth to be a sphere of uniform mass density, the weight of the body at a depth d is equals to r by 2 from the surface of Earth. If its weight on the Earth is 200 Newton, we have to find its weight at depth d is equals to r by 2. Here case 3 is applied because the object is below the surface of the Earth. For below the surface of the Earth, g is given by g naught into 1 minus v by r. Here they have given d is equals to r by 2, so we need to substitute d as r by 2. Here we can assume g naught as 10. So we get g as 5 meter per second square. Here they have given that its weight on Earth is 200 Newton. So mg is equals to 200 Newton. We have assumed g as 10 meter per second, so mass is equals to 20 kg. Now we have to find its weight at a depth of d is equals to r by 2. So So the new weight at a depth of d is equals to r by 2 is 100 Newton. So the third question is two planets A and B of radius r and 1.5 r have densities rho and rho by 2 respectively. Here we need to find the ratio of the acceleration due to gravity. So there are two bodies A and B. For A, the radius is given as r and its density is rho. For the body B, they have given radius as 1.5 r, which we can also write it as 3 by 2 r. And the density is given as rho by 2. Now we need to find the ratio of acceleration with respect to B to A. Here case 1 is applied since the object is on the surface of the Earth. So this is equation 1. Now from equation 2 and 1, we need to find the ratio of GB and GA. So here we get the ratio of acceleration due to gravity at surface of B to A is 3 by 4.